he's serenading his prize cat Mingo. He was the grand champion of the Elkhart County Fair in 2012.
Where's Mingo?
Math man can't be with his students, then he won't be with his prize cat either. Us cat people must stick together. Ha ha ha!
Hey everyone, and as you can see, I got Mingo back before Catwoman turned him into a furball. And so Mingo says hello. He says everybody should stay positive as we do this e-learning, and I don't know, I think he wants to get down. He must be in a bad mood. And so welcome back. It's Friday, and so Mingo's running off. He might want to go drive his Ferrari, or maybe he's going to go read the newspaper. So, but whatever he's doing, he's feline good, and so hopefully you're feline good today too. So get your notes, get a pencil, and get ready for another day of e-learning. And so looking forward to it. Like a Friday. With all this going on, it kind of seems like every day is the same day, but it is Friday. I don't know why when it's Monday, Friday seems so far away, but when it's Friday, it seems like Monday's coming quick. But it is our last day of e-learning this week, and so we do have an assignment, and your logic problems are due, and your warm-ups are due, so make sure you get all those things in. They don't have to be done today. Just get them done by this weekend and get them sent to me, and then I'll update PowerSchool. And so we find ourselves here today on the e-learning page, and just make sure to remember to fill in the attendance form right away and click on Friday, April 17th, and then we're going to scroll on down to see what we have in store today. And so for pre-algebra, we're going to actually have an assignment in the book. And so it's page 486, 7 to 12, 16 to 18, and problem 21. And so I also have a link. I scanned the page in case you can't find your book. Well, hopefully you can. And the odd answers will be in the back. And so you won't get that if you just look at my scan page. But make sure you do that. And our video for the notes will appear right here on Notes 114. But the notes you can click on and you'll get those, and make sure your warm-ups are done and logic problems are done. And so today we're going to continue on talking about the Pythagorean theorem, and we're going to do special right triangles today. And so just let me know. Most of you I've checked in with, there's a couple of you that haven't been getting things in. I need to know if you need paper copies, because the only time I can go to school is Monday morning, and so I have to drop them off. I could email them to the school, but there's going to be too many. I want you to be able to pick them all up at once, and so you'll just have them to the end of the year. And so make sure you let me know. Otherwise, I assume you're getting everything fine and sending me your papers. Okay? And so also, with these videos, it always seems like the algebra students like the videos more. At least they like them on YouTube. And so we always get a couple likes in pre-algebra, but maybe we could see more and see which class will win with the most likes. And so we always check those things out. And so it always seems like the algebra students always have the most likes by a couple. So, okay, so we're going to talk about some shortcuts. Now this is not critical 6th grade pre-algebra learning, and I just realized that I forgot to open up the Active Inspire, and so here we go. I think it will work, and it should open up here. And so just like in class, you have to wait for me to open Active Inspire. Remember that little picture, how it used to be? Well, here we are again. And so get the trash can out of here, and we just want to annotate and get that ready to go. And so here we are. And so just like old times, you have to wait for me to open that, and I have to wait for me to open it again. And so we ended the notes on Wednesday with finding a face diagonal and talking about their shortcuts. And so if we had a cube means that the side of the cube, the face of the cube, is a square. And so if it's 5 by 5, the face diagonal, there'd be a shortcut. So instead of doing 5 squared plus 5 squared and getting 25 plus 25 to give you 50, and then just typing that in and getting 7.012 or whatever it is. You know, if we would simplify the square root, we could see a shortcut, because square root of 50, if we simplify it, is 25 times 2, and then the square root of 25 is 5, and so that 25 breaks out as a 5, and we simply get 5 square root 2. Well, then we realize that if we use the shortcut, we can just realize what the answer is. We don't actually have to calculate it. And it's so much faster than using this. Everybody thinks this is the answer to everything. And it's not. And so we want to make sure that you can be as smart as a calculator. Calculators were programmed by humans. You are a human. That means you are smarter than a calculator. And so this would be 5 square root 2. And then we talked on Wednesday that if we wanted to find the space diagonal, that would be going from opposite vertices of a cube. We could do the Pythagorean theorem twice and get 5 squared. 5 squared gives you 5 square root 2 for that one. And then do this. But then we said on Wednesday, and we discovered that length squared plus width squared plus height squared gives you the diagonal squared. And if you have 3 groups of 25, that would be giving you 75. And then the square root of 75, if we could just type it in, but then we would lose the beauty of mathematics. Like snow falling on an April morning. So beautiful. Maybe not. And so this breaks out as 25 times 3. And so 25 times 3, the square root of 25 is 5. And so instead of 5 square root 2, it's 5 square root 3. So there was a shortcut there. That if you're ever asked for the space diagonal of a cube, you just take the side length and you simply tack on the square root of 3. And it's like, whoa, how'd you get so smart? It's amazing. And so we're going to build on some of those shortcuts today, and even the book. And so we begin the shortcut idea on the Pythagorean theorem in pre-algebra. We expand upon it in algebra, and you are the Jedi Master when it comes to geometry with these shortcuts. And so you'll be really good at it by then. And so we're just starting out. And the expert in anything was always once a beginner. Remember that? It used to hang in the classroom. Well, it still does. We're just not there. And so here we go. So if you have a right triangle, that's isosceles. That means 2 sides are the same. Notice it'd be half of a square. See how that shortcut works? But we're not going to draw the whole square. And so instead of saying we have a diagonal of a square, we're going to say we have the hypotenuse of a right isosceles triangle. Well, in a triangle, when you have 2 sides the same, you have 2 angles the same. Well, then every right isosceles triangle has the exact same angles. If this is 90 and 3 angles add up to 180, that means these 2 are 90 together. And so each one is half of 90. So many times we call this a 45, 45, 90. We just name it by its angles. But those are the angles of every single right isosceles triangle. And so if you have the shortcut and we want to find the side, many times we don't let that side be x. We say if 2 angles are the same, then 2 sides are the same. And those would be the legs. And if those are the same, if you want to know the hypotenuse, you just write the leg down and you tack on a square root 2. So when you have a right isosceles triangle, the hypotenuse is always the leg times the square root of 2. And so in a square, when we're doing the face diagonal, so that's not a very straight line, if we called this 7 and called this 7, you instantly know without doing the square root of, or 7 squared plus 7 squared equals 49 plus 49 is 98, and the square root of 98 is the square root of 49 times 2, which is 7 square root 2. That's a lot of work. You just tack on a square root 2. Woohoo! And we got that. So that's one shortcut that you will use on your homework today. Then there's another shortcut, and it has to do with equilateral triangles. Well, in an equilateral triangle, you have all 3 angles the same. And if you have all three angles the same, you have all three sides the same. And so that's not earth-shaking. They're all 60, and the sides could be anything, small, big, or actually that's small and this is big. And so we do that. But what we're going to do today is just focus on part of it, half of it, because this is going to make a right triangle. And this right triangle, we could use the Pythagorean theorem on, because you can use it on right triangles, regardless of what the Scarecrow says in the Wizard of Oz. We don't want to get into copyright trouble, so we don't really want to show the clip. But the Scarecrow, when he gets his degree, if I only had a brain, and then he says some things, and he goes, oh, the square root of any two sides in an isosceles triangle equals the square root of the remaining side. Woo! Wrong! The Scarecrow's wrong. Whoever wrote that, totally wrong. The square root of any two sides in an isosceles triangle is equal to the square root of the remaining side. Wizard of Oz, wrong. Don't learn math from movies. Don't get all your learning from movies. Get it from the right places. And so when we look at that, you want to see what the Scarecrow did? Don't write this down. He says this. So if we had a triangle that was 9 by 9 by 4, he says the square root of any two sides in an isosceles triangle equals the square root of the remaining side. Well, guess what, buddy? The square root of 9 is 3. The square root of 9 is 3. The square root of any two sides in an isosceles triangle is equal to the square root of the remaining side. And 3 plus 3 is 2. Don't think so! And so, even though the great Oz told him that he had a brain, he had the same brain he always had. Just be confident, stay positive, and you'll be feeling good. And so, here we go. Let's go back to the shortcut right here. The real Pythagorean theorem, where the squares of the legs, the sum of the squares of the legs, equals the square of the hypotenuse. And so, but instead of calling this side x, we're going to take and call it 2x. Now, why would you want to do that? Well, because we can. But then notice how this side right here is half of this. So then we could call it x, because we wouldn't have to go fractions. We don't like fractions. They frustrate us. But then you'd want to know this side. Well, you could do this by calling it the height. And we could figure this out. We could do x squared plus h squared. And you're like, I'm not in algebra yet. Yeah, but the next time we're together, you're going to be in algebra. Scary? And so make sure you're ready. And so we have x squared plus h squared equals the quantity 2x squared. And if we solve this, this becomes really cool. X squared plus h squared equals 4x squared. And we're going to subtract an x squared from each side. And I'm not going to show all the steps because I'm writing with a mouse and it takes forever. So h squared is going to equal 3x squared, because there's 1x squared over here that you're going to take away. And that gives you 3x squared. And then we're going to square root both sides. And when you do that, we haven't taken the square root of variable expression, but the square root of x squared is just an x, and the 3 stays in prison. And so that becomes x square root 3. So there's some shortcuts here. And this height is no longer an h, it's x square root 3. And so everything in this triangle, we can find all the sides, and they're all defined by the short leg. If you know the short leg, the hypotenuse is just twice the short leg. If you know the short leg, the long leg is square root 3 times the short leg. And so notice how square root 3 is a smaller number than 2. The hypotenuse is always the biggest side. So 2x is bigger than square root 3 times x. So the leg is always square root 3 times x, not the hypotenuse. Okay, so I got to fill in this part. Sometimes I forget, so I'm going to go sit in this corner. And so if you know the short leg, here's the short leg. Well, then what's the long leg? It's just, oh, that's not the long leg. That's the hypotenuse. So what's the hypotenuse? It is the short leg times 2. Because a 30, 60, 90 triangle is really half of an equilateral triangle. So half of 60 degrees is 30 degrees. And if you have half of one angle and then you have a side, you got the hypotenuse is twice as much. And so the hypotenuse is 2x. So this is a 60-degree angle. And this is a 30-degree angle. But see, the thing is, I almost misspoke there. It's hard to talk right with the mouse and do all these things. Notice that this is 30, this is 60, but it is not this side that is twice as much. That is not true. Not true, not true, not true. So don't think that. Okay? And we told you not to think it, so don't think it. It is the hypotenuse that's twice as big, and the longer leg is the short leg times the square root of 3. Not short log, short leg times the square root of 3. And we always know that the hypotenuse has to be the biggest side, and so the biggest side is 2 times x, not square root 3 times x, because square root of 3 is like 1.7 blah blah blah. So, okay. So we're going to do some example problems, and then we're going to move on. And I'll give you some homework hints. Okay, so here we go. Get the sound off my face. So if you're given a picture like this, and they give you one number, 8, and then you go, well, what is 8? Is 8 the hypotenuse? Is it the short leg? Is it the long leg? Which one is it? Ian, Bowtie Man. That was a nice picture last year. And so the short leg times, oh, that is the short leg. That's what I asked. And so 8's the short leg. Good job, Ian. Ian, how do we find the hypotenuse? The hypotenuse is which one? Right here. Good job, Ian. And so that becomes 16 because it's twice as long. But they didn't ask for that. The question mark, Mr. Nice, and the question mark's down here. So what would that be? How do you find the long leg? Ian? Oh, it'd take the short leg times the square root of 3. And so that's what we're going to do. And I just found all 3 sides of a right triangle just knowing the short leg. But that only works if it's a triangle that's half of an equilateral triangle. So that means it has a 60-degree angle, which then obviously makes this a 30-degree angle because you have to add up to 180. Okay? So we could just skip over to this one. And on this problem, this one's harder. You only get these in algebra. But I just wanted to show you what's coming. And so you're not even going to have anything this hard today. And so, like, if the long leg is 15, to go backwards to the short leg, well, I'll change colors. To go backwards to the short leg, and how do I know that's the long leg? Because this is the 60-degree angle, and this is the 30-degree angle. And when the angle opens more, you get a bigger side. And when it opens more, you get a bigger side. Remember, closed mouth catches no flies. And so the shorter side is across from the shorter angle, smaller angle. So to go backwards, you would actually divide this by the square root of 3. And then you'd have to rationalize the denominator and do all that stuff. All things we get to look forward to. But not today. It's snowing outside. And so when we have the short leg, which is 15 over the square root of 3, to get the hypotenuse, what do? The hypotenuse is always how many times the short leg? What is it, Josiah? Yes, it's 2 times. So if I was going to multiply the fraction 15 over the square root of 3 times 2, do I multiply top and bottom by 2? Just the bottom by 2? Or just the top by 2? Josiah? Just the top. So that would become 30 over the square root of 3. And again, we would rationalize the denominator and multiply top and bottom by square root 3 and get 30 square root 3 over square root 3, which would give you 30 square root 3 over 3, which would give you 10 square root 3. But you don't have to worry about any of that. I'm just showing you what's in your future. So then we have this one. Well, we're not doing square root 3s on this one. This has a 45-degree angle in it. And since the angles of a triangle have to add up to 180, and this is 90, that means these two are always complementary, which means, Tennille, complementary? Yeah, that says you look nice today. Yeah, that's a compliment. But what else is complementary? Oh, they add up to 90. Good job, Tennille. And so that means these are both 45. And so If in a triangle you have two angles the same, you have two sides the same. It's isosceles. Oh, isosceles, oh, isosceles, how beautiful are your two equal sides. Oh, Tannenbaum, oh, Tannenbaum. I don't know the words to that one. And so, these are both 8. And in a 45, 45, 90 triangle, if the legs are both 8, the hypotenuse is just the leg times the square root of 2. Look how quick that was. That's quicker than snow melting on an April afternoon. I'm telling you, you don't have to shovel the driveway. Just wait an hour. It will melt. Unless mom and dad tell you to shovel the driveway, then of course you should listen to them. Okay, so let's go over to this last one here. This is a 45. This is an A. This is 30. Well, let's label all the sides in terms of A. Well, in this triangle right here, these are my two equal sides. So if this is A, then this is going to be A. And what's the hypotenuse going to be, Katie? A square root 2. Excellent. Over here, this is a 30, 60, 90 triangle. So I need my highlighter. And so in this triangle, if this side, the short leg's A, then how do we figure out the other two sides? Well, you can look up on your notes. They'll be right up there, except I erased the answers. But you still have them. Or you can rewind the video. Beep, beep, beep. We're backing up. And so if this short leg's A, the long leg, is it 2A? No. Just because the 60 is here, that does not mean that this side is twice as big as this side. No, 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 no. Don't do that. That's wrong thinking. And so that's thinking like it snows in April and the snow's going to stay for a week. Not going to happen. And so this A, it's the hypotenuse that's 2A. And the short leg, Max, if the short leg's A, what's the long leg? Got to look it up. Just back up the video. See what we said. Oh, good job, Max. The long leg is just the short leg times the square root of 3. And then we can write crazy answers like the 8th graders do. What's the length of AB? Well, the length of AB is equal to A plus A square root 3. And then we, in algebra, learn how to add square roots together and radicals and FOIL them and do all kinds of fun things. And that's what class you're going to be in. Algebra. The next time we're together. Oh, I don't know if I'm ready. And so here we go. Okay, so now on your homework, it's on page 486. I have it typed out on the e-learning page. See right here. Whoa, where are we at? Some of you asked me for the homework, and it's right here, page 486, 7 to 12, 16, 18, 21. So you want to get your book out. Now, on the book assignment, I got it right there. Whoa, look at that. You have to find the unknown lengths, and it says in simplest form. That does not mean, Thomas, you just type it in your calculator. Use the shortcuts that we have in the video, just like the homework we did the other day. And so, on this, if this is an 11, and these are both 45, that means this is an 11. And so if this is 11 and this is 11, that means this is 11 times the square root of 2, or 11 times the square root of 3. Now you have choice. You can just write problem 7 down on your homework, and you can write x equals, y equals. But you know what would even be better than just doing that? You could just copy this picture. And instead of writing x and y, you could write 11, and you could write 11 square root 2. And then you don't have to write x and y, and you could just draw the picture and fit it right in. Now in our homework, we put 8 underneath 7, not across. Don't get bad habits. And so you could either write x and y, or you can label this. So you have to do the first 12. Then you have to do 16, 17, and 18. Well, these could be a little trickier because they give you a decimal. Oh no, not a decimal. Or on problem 17, they give you the hypotenuse. Well, if it's the leg times the square root of 2, I wonder what part of this number just ends up being the leg. And on this problem, they give you the long leg. Well, the long leg is the short leg times the square root of 3. I wonder what the short leg is. And then the hypotenuse is just twice the short leg. So you can fill that in. And then I gave you the challenge problem, 21. Why is this the challenge problem? Because here is a 30, 60, 90 triangle. And Mr. Nyson, on a 30, 60, 90 triangle, the long leg is supposed to have the square root 3 with it, not the hypotenuse. So what in the world do we do if they have the hypotenuse has the square root of 3 and not the long leg? I'm so confused. Wait. The hypotenuse, half of it, becomes the short leg. And the short leg is half of 10 square root 3. Well, what's half of 10? And then just write a square root 3 on it. Then once you know the short leg, even though it has a square root 3 in the answer, you multiply that by the square root of 3. What's the square root of 3 times the square root of 3? That'd be the square root of 9, which would just give you a 3. And then this answer right here has a square root 3 in it. This answer right here will have a square root 3 in it. But this long leg, which normally has a square root 3 in it, won't have a square root 3 in it because I'm going to multiply by the square root of 3. And the square root of 3 squared is 3. And then that will give me this answer, and that will give me this answer because it's a 45, 45, 90. And then this answer will have a square root 2 in it because it's this times the square root of 2. So we look forward to seeing you what you get on that. And so send your homework right away. Don't wait, because then you might forget. Did I send the homework? Did I not send the homework? And then I always try to reply back. To keep track of all your papers, once you send it, I reply back and say, got it, and I print a copy so I know which ones I printed and which ones I haven't printed. And so I print it right away, and then I get them graded, and I put them up in the Power School. Of course, that all takes me a little time when stuff's coming at me all the time. So we miss all you guys. Enjoy the snow. It's starting to snow already this morning. And so we look forward to Monday, and we'll try to have some new things planned for you then. So email me any of your questions, and hopefully I didn't misspeak too much. I do sometimes, and I apologize for that in advance or for today's mistakes that I don't know I've even made. It's just like you. You make mistakes in your homework. Nobody makes mistakes on purpose. And so if you make them, you don't know you're making them. So I might have made some, and I don't know I made them. So, hey, we'll see you guys later.